Hello, everyone, and I'm very honored to involve in this kind of international, ESA international fellowship, and have the opportunity to share with all of you some of my preliminary research on enhancing transboundary climate governance via global city network and the land spatial optimization. So this is the outline of my presentation. And first, let us take a quick look at the research background. According to the UN climate change conferences in recent years, it is found global emissions are not in line with modeled global mitigation pathways consistent with the temperature goal of the Paris Agreement, and there is a rapidly narrowing window to raise ambition and implement existing commitments in order to limit warming to 1.5 centigrade above pre-industrial levels. As a result, we believe more effective international cooperation and credible initiatives are encouraged to contribute to bridging and implementation and the emission gaps. We think that collective and participatory decision-making processes can promote equity and reduce the disruptive consequences of rapid system transformations as countries chart their ways to net zero emissions. So you can see this background in this figure as well. Apart from the pressure of the climate change mitigation, another critical issue also raised a widespread concern, which is adapting to climate change. Some climate-related risks, such as flooding, urban heat wave, have occurred with high frequency in recent years, especially in China. This is the figure of Chinese flood disaster in recent years. In response, in China, we have launched a series of actions or initiatives, such as the State Council in China issued a dual carbon action. In the meantime, the ministries in China have issued adapting to climate change 2035. We have implemented a series of actions. That's how China do. In this process, another interesting issue have also raised a widespread concern, which is the transboundary climate risk. And according to the Global Transboundary Climate Risk 2023, 10 transboundary climate risks of global importance have been identified, which include finance, human health, well-being, livelihoods, ocean and coastal terrestrial shared natural resources, energy, human mobility, supply chain in the sector of agriculture and industry. So there are a lot of information in this kind of report. And also in Europe, a series of projects have also been carried out to assess the transboundary effect associated with international trade. In this process, 4 climate impact categories have been considered, which include agriculture, labor productivity, energy, and river flows. In this kind of assessment, they have implemented a kind of scenario simulation, and the results from the 2 main scenarios are presented in this figure: a high emission scenario and a 2 centigrade world scenario. For instance, under the high emission scenario, the EU would have a 3.95 billion euros GDP loss due to climate impacts in Latin America. The sectors that channels both of this kind of transboundary effects is found to be agriculture, followed by labor productivity. Last year, in the COP29 UN Climate Change Conference, the transboundary and cascading risks on the climate change has already been highlighted, as well as the urgent need for international cooperation to strengthen climate action and achieve the UN sustainable goals. As indicated in SDG Progress Report in 2024, climate change worsens the water scarcity problem. In the meantime, transboundary river and lake basins are shared by 153 countries, supporting 40% of the world's population. However, less than 1/5 of these countries have operational arrangement of their shared transboundary waters. In this context, TCG, transboundary climate governance, has become indispensable in addressing climate risks with collective effort. So then, what is TCG? It can be perceived as a set of rules, protocols, and relationships attempting to enhancing the synergic capabilities in combating climate risks that transcend national borders through biophysical and socioeconomic linkages. This is the background, then we made some literature review on it. The emergence of transnational and global city networks aligns with the imperative for TCG through coordinated efforts. So we think that to deal with TCG, global city network would be a very good approach. Extensive research has already recognized the role of city networks to address complex politics in TCG in responding to climate change. Climate city networks such as C40 and ICLEI establish cities as both locally rooted and global actors, facilitating governance actions for climate mitigation and adaptation. According to the report in EU, it is found city networks in Europe contribute to 27% of the greenhouse gases emission reduction targets set by the EU. So yeah, let's take a close look at some of the literatures. According to one of the publications exploring the driving mechanism of urban climate action, it is found that local mitigation planning is associated with the configuration of network cities, and network membership is key among network cities. Yeah, this is one of the publication. Another one adopt an interdisciplinary approach to identify the key drivers of climate actions. So this table illustrates the framework of thematic points and key city attributes of climate actions in city networks based on 3 fields of studies. And it consists of 13 attributes on the 4 themes, which are networking context, political economy context, and social cultural context, and the environmental context. Another research in Indonesia, in Asia, nearly 40 semi-structured interviews with Indonesian city actors and a preliminary catalog of cities participating in transboundary municipality network revealed that risk-averse selection criteria, insufficient impact assessment, and duplicative institutional efforts reinforce disparities between primary and intermediary cities. Then, to effectively build adaptive capacity in this kind of vulnerable regions, TMN, transboundary municipality network, should remove participation barriers for intermediate cities, improve incentives for institutional collaboration, and adopt more rigorous evaluative metrics. Another research in German cities, the connections between the individuals and climate protection related organizations, projects, and events are analyzed, and the diversity of the different types of organizations is examined. It is reviewed the diversity of organizations and suggests a typology of climate change activities, as well as a typology of climate change projects and organizations which can be used to better coordinate and support the cooperation of different sectors, as illustrated in this kind of figure. In recent years, scholarship on climate city networks has illustrated that such network can no longer be understood as homogeneous groups of organizations. Rather, in recent years, they show heterogeneity in how they seek to attract and emerge with member cities. In studying 22 real-world climate city networks, yeah, this is the 22 city networks. We've in this publication, they uncover 5 distinct types of networks with an active member base. The typology illustrates the rich but bounded variety of climate city networks, which can help to clarify how climate city network can be effective in encouraging their member cities to take local climate actions. So based on this literature review, we then raised 2 research questions. The first one is the proposition of the framework to link TCG, transboundary climate governance, and the global city network, as well as proposing some priorities to promote this kind of links. The second one is the measurement on the spatial distribution of city network and the measurement on spatial influence of TCG. So these are the research questions. In order to address these questions, we have selected our study areas. We have selected countries and cities worldwide. At the country level, both the developed and developing countries are included. At the city level, we include the widely recognized city networks such as C40, ICLEI. In the meantime, we also include some other city networks such as UBC, MP, CNCA, and YCP. The number of cities they include, their primary category, such as mitigation or adaptation, have been listed here, as well as their website. This is an illustration of the website of C40, and as we see, the primary contribution of C40 lies in raising climate ambition, influencing the global agenda, building a movement, scaling up climate action. And London in the UK have also joined this kind of C40 network in 2005. In this website, they provide some specific networks such as private building decarbonization network, net zero vehicles network, public transport network, and so on. They also provide some specific case studies, such as London Power's ahead with zero emission buses. Some other case studies are also provided here. And this is another illustration of ICLEI website. On this website, they have published the recent 327 ICLEI activities. For example, they have published this kind of activity called Town Hall COP Initiative, which is associated with the sustainable development goals, such as resilient development, equitable development, cycled development, and green development. So these are the illustrations of some city network. Then we adopt some specific method to deal with this problem. The first one is the literature review and bibliometric analysis. We retrieve more than 2,000 publications with the keywords of transboundary climate governance and urban climate. We summarize the keywords and research areas, and also attempted to retrieve the scale, city name, approach, and the effective of the initiatives they adopt. Then we attempted to implement a kind of meta-analysis to review and quantify the influence of city network on climate change mitigation and adaptation. Thirdly, we use the network analysis to measure the distribution of the city network. Here we introduce another metric called national proximity via ICLEI Global City Network to transform the city-to-city relationship to country-to-country relationship. The equations of this kind of metric is shown here. It is the multiplying of the number of cities in one country with the number of cities in another country divided by the distance. Here we use the spatial distance here. So this is the metrics we used to measure the national proximity. In the end, we use the regression and the spatial analysis to explore the influencing mechanism and spatial spillover effect. In terms of the measurement on the distribution of the city network, we employ another metric called distance metrics to describe the magnitude of the dispersion or aggregation of the distribution of the network. This metric can help to signify the spatial equity of the enrollment in city network membership. In the end, is the regression and spatial analysis. First, we use the very simple standard linear regression model in OLS. And then we also use the generalized additive model. This is a kind of nonlinear regression model. And in order to capture some potential spatial spillover effect, we also include the spatial regression model. Yeah, these are the models we use in this preliminary research. Then is the preliminary result. Currently, this is the spatial distribution of climate change mitigation, which is measured by carbon emission. Here we can find that the mean value of carbon emission is more than 300 million tons, but there are very distinctive spatial disparities with regard to carbon emission. China and India, yeah, we have very high values. And second is the spatial distribution of climate change adaptation, which is measured by the climate risk. This value is measured by, I think, bio-organization in European countries. We also calculate the mean value, the variance, the standard deviation of this climate risk index. It is from the developed countries. They generally have high values of climate risk, as well as some countries in Africa. Yeah, we can see here. And then this is the spatial distribution of C40 cities, the C40 network cities with the selected countries combined with climate change mitigation and adaptation. In this figure, we select 97 countries in total because of the data availability problem. And here, the countries with the dark colors means they have both high values of climate change mitigation and adaptation. The countries with light color, they mean which indicate they have both low values. And we can see the spatial distribution of C40 can cover most of the countries with high climate change mitigation and adaptation. But I think Canada, they right now they don't have cities in C40 city network. And this is the spatial distribution of ICLEI cities with the selected countries. And here, because there are more cities in this kind of city network, and it can be found that the very clustered spatial distribution in the United States and in the European countries. There are a lot of cities in these two areas. Yeah, we can find here. And we also include other climate city networks such as MP, CNCA, MYCP, UBC in this kind of figure. We found that here, in some major primary cities in the United States, in the European countries, in China, and in India, some cities, they engage in or they participated into more than one global city network, such as the city you can see in China. Some cities they engage more city network. Here, the dots means the bigger the dot is, the more city network they have participated into. Yeah, this is the spatial temporal distribution of city network. Based on the metrics we mentioned before, to measure the distribution of city network, it is found UBC here. It has the most aggregated spatial distribution of the city network and the most dispersed distribution of the city network is CNCA, followed by ICLEI and C40. Yeah, they have shown different spatial distribution. And in the end, we use the ordinary list squares to build a linear regression model of greenhouse gas emission here. It is primarily referred to carbon emission on GDP, population, and technology. It is found that the result performs satisfactory with the R square of 0.89, and it is found that GDP has the highest correlation coefficient in this kind of ordinary least square model. And then we also use the nonlinear regression here. I want to explain why we both use linear and nonlinear regression models here, because we found that we cannot determine the relationships between carbon emission and GDP, population, technology with 100%. It can be linear, and it can also be nonlinear to some degree. So we include both models. Here we found that the result of the nonlinear regression model performs better than the linear regression model. The figure plots here shows the GAM smooth terms for the three standardized variables: GDP, population, and technology. Then this is the result of the spatial distribution of the network. I mean, here we transform the city network, the city-to-city relationship into the country-to-country relationship, and then produce this kind of network map. The spatial network map was constructed by normalizing the data in each row of the spatial density matrix, and we selected the top 7% of the most important and relevant countries for each country in this map. Some active network nodes can be found in this map, such as the USA, the Republic of Korea, as well as Brazil. Yeah, these countries are quite influential in the network. And based on this kind of spatial network, as well as some diagnosis of spatial effects in the ordinary least square model, we then use the spatial regression model to capture the potential spatial spillover effect. In the result of this kind of model show that GDP and the population remain significantly positively correlated with carbon emissions. And we also find that the significant positive spatial coefficient exists. It means that it justifies the neighboring effect here in this model. And also the spatial autoregressive model has better performance compared to the OLS model with a little higher value of R squared. So these are all the quantitative analysis of our results. And then based on this result, we have provided three priorities or discussions based on this result. The first one is we believe that the climate city network should be strategically guided to facilitate exchange and consensus building on climate adaptation with shared aquatic or terrestrial resources. So this can be realized through technology and knowledge transfer. Secondly, it is crucial to integrate heterogeneity, vulnerability, and spillovers to achieve climate equity to enhance the performance of climate city network. This has also been highlighted in recent UN climate change conferences. And thirdly, there is a critical need for cross-border data and knowledge sharing form within the TCG framework, facilitated by city networks and supported by interdisciplinary experts. I think all of you here can be of great help on this. Yeah. So these are the discussions of this research. And in the end, I would like to squeeze some time to briefly introduce our research team and our research areas. I'm from Huazhong Agricultural University, which is a university in Wuhan in central China. We have also established an interdisciplinary research center called Terrestrial Spatial Governance and Green Development. The primary research areas of our research center lies in climate change and regional sustainability, ecosystem services, and socio-ecological system interaction, spatial governance, regional development, and spillover effect, land development, transportation, and ecological effect. Currently, we are doing some projects on these topics. The first one is what we are doing right now, the maintenance and improvement of land spatial resilience to support high quality development. The second one is the agricultural sustainability in the context of global climate change. And based on this project, Julia and Lindsay will be invited to China next month. And the third one is transboundary spatial optimization of construction land with the constraint of ecological regulation. This is funded by the National Science Foundation of China. And the last one, this project actually is collaborated with YASA in New York. So yeah, the topic is about the trade-offs and synergies between climate mitigation and adaptation in relation to regional land use change. Actually, the feature of our research group lies in land use modeling. So we do this kind of land use modeling in both urban and rural areas. In urban areas, we are doing some research on identifying trade-offs and co-benefits of urban form on heat wave exposure and carbon emissions. We select some metrics to describe the urban form and try to explore the relationship between the urban form metrics and carbon emission, as well as population exposed to urban heat waves. And yeah, these are some preliminary results. And also we have carried out some land use simulation and optimization in the context of climate change using some artificial intelligence models such as CA. This kind of work has been done in some specific cities such as Wuhan. Yeah, this is my hometown, Wuhan. And also in Guangzhou, another city in southern part of China. And in rural areas, we have carried out the spatial optimization of cropland for climate change mitigation and adaptation. In this kind of research, we focus on cropping, how to optimize cropping to realize the spatial optimization of cropland. And these are some preliminary results. And we also establish 3 scenarios to review it, to realize it. For example, the mitigation scenario, adaptation scenario, and in the end is the combination of these 2 scenarios. So that's all my presentation. And I believe that along with the expanding of city network, the increasing links in our research network will be realized in the very near future through this kind of international fellowship. And thank you very much. Your comment is highly appreciated. Thank you.
Thank you, Chen, for the nice presentation. But if anyone has got any question that is in Zoom, please raise your hand or just unmute yourself. In the meantime, if there is any questions, Chen in the room. I'll start with one. You talk about your indicator
Yeah, I can.
of climate risk.
Yeah.
That you put in one of the earliest, and when you refer to it, you call it adaptation risk or adaptation, and I was one confused.
Which slide are you?
Go down.
This one.
Yeah, I think it appears in that one. So that you model both.
Mm-hmm.
Yeah, so is this, you said that this risk is calculated from a group in Europe?
Yes,
And when you refer to it, you call it adaptation. So I just wondering what is in that metric? Do you
mean
what-
risk matrix?
Yes.
Okay.
Yes.
Here it is kind of illustration of this map actually.
Uh-huh.
And for the, here, for the very dark values here, it means that the countries, if they have this very dark values, they have both high values of carbon emission as well as climate risk.
All right. Because
Yeah.
when you were talking, you were saying adaptation. So it's
Oh.
climate risk.
Yeah, climate risk.
Okay.
So yeah, well, here climate change adaptation is measured by climate risk. So this is what we think now. But yeah, maybe this is not so.
That is my confusion. Do you
Okay.
think that they go in parallel? That there is, if there is more
Yeah.
risk, there is more adaptation?
In our study, we think so, but I know that for the measurement on climate adaptation, they can include a variety of dimensions.
Yeah.
But here we don't have enough data
Right.
to measure it very completely.
Yeah.
So here we just use the climate risk, this kind of index,
Yeah.
to signify the climate change adaptation degree.
But more risk is not necessarily more adaptation.
More risk, yeah. More risk means the lower values of adaptation. Yeah.
Right. More risk,
Yeah,
less
they are-
adaptation.
Yeah, they are the opposite relationship.
Okay.
Okay, thank you.
For the question, could I ask, would you mind to talking some details about how you calculate climate change risk? Because you mentioned a lot.
Yeah.
risks.
Okay.
Could you share some details about it?
Okay, thank you very much for your question. Actually, for this climate risk measurement, we have, it is not carried out by us. We just extract the values from a report by European Union project. So they actually calculate it. I remember they established a kind of framework, index system to calculate, use a lot of indicators. Yeah, this is how they achieve it.
Can you go back to the nonlinear regression, please?
Non-linear, okay.
Yeah.
So you want to check the result or the
Or the model, I just want to know
model.
the what's the categorical variable you apply
okay, here?
Yeah.
Mhm.
and output, yeah.
Okay. Here,
Just start. Yeah.
do you mean here?
Nonlinear, yeah, what's the categorical variable and then the dependent variable?
My dependent variable is carbon emission. Carbon emission, the total carbon emission is the dependent variable. And the independent variable is population, GDP, and the technology.
Yeah, that's a carbon emission, it's a continuous variable. So in this nonlinear regression, it's a binary logistic or what's the binary logistic of a bit?
It is not by probit or ordinary least square. You can regard it as a kind of this model, GAM. It is an extension of multiple linear model. It combines together. So there is not a specific value for each variable. It is a kind of you can see maybe an equation of these variables to check their relationship. Yeah.
And it's about technology variable.
Mhm.
I'm not sure what is from the index as well, or
Mhm. You mean the
technology.
knowledge?
how you
You
calculate.
measure it. Yeah. You mean how we measure the
the
variable
technology.
technology?
Yeah.
Here, the technology is measured by the percentage of the third sector industry, as well as the publications, the scientific publications. So this is how we measure it. Because we just have
Yeah.
this kind of data from the World Bank. So we think we also refer to some literature, and they also use similar ways
Right.
to measure it.
So your observations, are they at the city level or the country level?
So that's a very good question. And for my research, we focus on city networks. But when we have this kind of regression analysis, we have the dependent variables at the country level. So we need to transform the city to city relationship to the country relationship. So in the end, I mean, the regression analysis, the result of the regression, they have been implemented at the country.
So the network bit only comes into spatial regression at the end.
Yes, exactly.
And the network bit is
Mhm.
basically for a country level
Mhm.
value, you're using
Yes,
a gravity model
yes, exactly.
between the
Yeah,
distances between
the
population
countries,
centers,
yeah,
between countries,
between the countries, the
between
centroid,
cities.
the centroid of the countries.
centroid.
Yeah,
Is
yeah.
the distance between the centroid of the
Mhm,
country.
mhm, mhm. But we consider, so this kind of spatial matrix is both consider the number of cities, the number of cities in city networks in one country, as well as their spatial distance. So that is also,
That's the metric, isn't it?
yeah, the proximity, yeah.
The proximity.
Yeah. This one.
Done.
Yeah, this is also the question. Okay. That is also a problem here. We want to,
There's just distance, there's no distance to k, so there's no distance squared or anything like that.
no distance square, just the distance.
Just
Yeah, the distance. Yeah, we want to maybe in the future to replace it by some other approach if we have data to have a better way to transform this kind of city to city relationship to country relationship.
Is there much use of this sort of metric elsewhere? I mean, it looks like a gravity model to me.
Yes, it looks like.
Yeah.
So actually.
So you look at
Mhm. Yeah.
migration between city and city, and
Yes,
you look at the distance
exactly.
between them all and the
Yes.
interactions between all the cities.
Yes, exactly.
So
This is how we build this kind of relationship. Actually, it is on the basis of gravity model. Yeah. But we are not quite sure whether it is correct or not, but just maybe a preliminary attempt to deal with it. Yeah.
and this is also that go into your spatial regression.
Yes.
And that's what's coming out as
Yes.
significant in your spatial regression.
Yeah.
No, it's not. You said. I can see this spatial regression analysis.
You want to see the network one?
Yeah.
Yeah.
That one.
This is the spatial regression. We have the spatial correlation coefficient RHO. Yeah, that is the we use the spatial regressive model, and we found it is significant. So there is a kind of spatial spillover effect through city network. Yeah, this might be our conclusion right now.
So, is it a neighborhood effect around about neighboring countries then
Mm-hmm.
that goes into the
That's one to the row.
row, or is it?
According to the result right now, we can just make a conclusion that in terms of carbon emission, there is a kind of neighboring effect. The countries, they can influence each other, but we cannot give more implications here because the spatial weight metrics are just embedded in the dependent variables right now.
Okay, so it's just
Mhm.
autoregressive of
Yes, the dependent variable,
the
carbon emission,
carbon emissions.
Yeah.
In
neighboring countries, yeah, exactly.
Okay.
Okay, thank you.
There is no any questions online. Any more questions? Any comments?
Hello. Hello, teacher. Can you hear me?
Yeah.
Oh, well, at first, thank you so much for your presentation. But as just for me, as a beginner, I found the presentation really, I feel interest and full of information, but I still just have a small question about the network construction part. Well, I think it's different. It's based on the different skill, just like the country skill and the cities skill. But how could we get a link between between the country and the cities? Um, I want to know some more detail about it. How could we get the links or separate it? What could we do more work about it? That's my question.
Okay, thank you for your question. And actually, this is also a very good question. And currently, we just how we deal with the city-to-city relationship and country-to-country relationship. We use a very simple way. We just kind of NPM metric to transform them based on a model like gravity model. Yeah. But in real world, I mean here, in real world, how the initiatives in city networks can influence the relationships among countries. They have actually some specific networks like here, and for these networks, they have implemented a lot of activities worldwide. So this is actually in real world how the city network influence the country to country relationship in climate change mitigation and adaptation. But in fact, we do not think, for this metric, there are a lot of space to optimize in the near future. Maybe, for example, Julie has mentioned for the distance, maybe we can use some other data or metric to optimize, to signal real connection between these two countries. And also for the cities in the countries, here we just multiply them, but there may be other ways to check whether they may have different degree of connection, because maybe city in China like Beijing and Wuhan, they have more close relationship, and Beijing and London, their relationships are not so strong. Here we cannot reflect this kind of differences. So maybe in the future we need to think about other things.
Okay, thank you.
Okay, thank you.
Okay, is there any other question online? Okay, I hear there is no more questions.
Okay.
Thank you all for coming to this Jesse Fellowship Seminar. I think we have soon another one.
We have one next week of the same
Same day, next week?
Tuesday.
Tuesday.
Tuesday next week. Looking forward to it.
and then I think the week after there's one more, but I can't remember the topic of that one.
Thank you all for coming.